Okay. I'd like to start with a very quick topic about one of the syntax you might be confused with, which is about how you do equality in IFO. And by the way, for lab number 1, we still have one more lab session to help you. If you still got questions there, I will be in the lab session tomorrow, both of them. So just ask me questions if you have any. Okay? Let me just turn off the lights for the chalkboard quickly. Okay, that's better. Okay. So let me talk about equality, especially how do you compare equality between references versus contents in IFO. Most of the concepts are simply just consistent with how you did it in Java, basically. But I just want to highlight the difference to you. There's some interesting part you have to be aware of. And I also give you examples. Okay, so same as in Java, if you want to compare references, use equal. Well, in Java, use equal. In IFO, just use equal, a single equal. That one's easy. And similar to Java, where you have to redefine or override the equals method that you inherit from the object class, similar in IFO. In IFO, there is a top class called any, A-N-Y, any. And that has a feature called isEqual. That's just like an equals method in Java. So you have to redefine that particular feature. Like the entry class you saw in lab number 1. I already did it for you as an example. Okay? And that's about the isEqual feature. What I want to show you is this tilde operator, which you saw I use it for the string. I can say string S1, tilde, S2. Okay? I would say this operator over here is like operator. It's not really like a method for you to call. It's just like an operator. The way it works is a little bit interesting here. I would say part of its functionality depends on isEqual. That's like a summary. Okay? Let's see the different cases. Oh, let me ask you a question. If I say O1 dot is equal O2, what would be the precondition? If I say O1 dot is equal O2, O1 and O2 must be of the same type. Okay, I agree. And how can we prevent from null pointer exception? Which one cannot be null? The O1, right? O1, the context objects. When you say O1 dot something, O1 cannot be null, cannot be void. Okay, so these are the two preconditions if you want to say O1 dot is equal O2. However, in the case of O1 tilde O2, these two preconditions are not required. Okay, let's see what will happen. So that's really the difference between the two languages we have. I need to highlight to you. So first of all, if O1 and O2 are actually both void, simply means null. So void in IFO simply means null in Java. Okay. If both O1 and O2 are simply void, then it's true. Void is equal to void. Okay, that's true. Second case, if, let's say, only one of them is void, but the other one is not void, of course, it's going to be false. Okay, that's the second case. And the third case over here is to say if both of them are not void, that means both of them can be used as context object. You can say O1 dot is equal O2, or you can say O2 dot is equal O1, right? So both of them are not void. That's what you can do. And the is equal here depends on the version you're using. If you have already redefined the is equal feature in your class, that version will be called. Otherwise, the default version will be called. Okay, pretty much like in Java. However, there's something I want to point out to you over here. Be very careful, okay? Based on what we have learned so far. When you use tilde, sometimes when the code actually compiles, it doesn't necessarily mean it's really exactly what you meant to say. Let's see this example here, okay? Let's see if you can spot it. Let's say we have a class called bank, and we have an attribute called accounts, okay? Array of accounts. Let's not worry about constructor, assuming that we already initialized the accounts to be certain size, okay? That's not the important points for this example here. Let's say we have a query over here. Detachable, I will talk about it next week when we talk about void safety. Detachable simply means that the return value can be void, positive. It may or may not be void. If the ID we are searching for exists, it's going to be something not void. If the ID does not exist, which means the account cannot be found, then we'll return void. Okay, that's why we put detachable over there. Okay, so now in this case, let me show you the implementation there and tell me, first of all, if it will compile or not. Okay. Okay, so we do a cross loop over there. We simply say across the accounts, array as cursor, and we talked about cursor last time, right? And then we say if the account's ID is equal to the ID we're looking for, then we'll set the result to be the account, the current account we're looking at. Question number 1, does this compile? The way we use the cursor over here, we say cursor.item. So I can tell you that one's OK. If we didn't say cursor.item, we might have some errors. Okay? How about this? Let me give you a little bit hints. Line number 12, does it compile? Yeah, tilde is actually like a binary operator. It's going to return Boolean always. And that operator does not have any precondition. Like when you say something plus something, right, you will never crash. You always get a result. Pretty much like a tilde over here, right? So basically, any expression can appear as the left-hand side or the right-hand side. So the answer to my question here, line number 12, compiles. Okay, first of all, it compiles, which means if you wrote code like this, you would just assume, oh, it compiles, so I should be okay, right? However, is that exactly what you meant to say? What are we trying to compare over here? The right-hand side of the tilde there is an ID, is a string. What about the left-hand side? Not integer. Account, exactly. Remember, cursor over here is a cursor to every element in the array, which is account objects. And cursor, the item here, is just the account. So you're comparing account with string. That's not really comparing the right things. However, unfortunately, this wouldn't be a compile time error. Wouldn't be. Okay, so you got to be very careful. So you just say false. Exactly. Why? Because remember, one of the cases is they are of different types. Okay, it will just give you false. Okay, that's something I would say you have to keep in mind just for using iPhone. Okay, for the rest of this semester. Now, can you suggest any fix to line number 12? Wow, exactly, right? We're going to say cursor.item.id. That's really what we meant to say. Okay, everybody sees this example here? Any questions? Yes.
What is the difference, if I change the symbol to equal?
Okay, what if you change? Okay, very good question. The question was, let me just get a new page and then I'll show it to you. I also make some source code available to you. Okay, let me say this. If we say, for example, cursor dot item tilde ID. First of all, we know that ID is of type string. And then cursor is simply a cursor to accounts. So cursor the item is going to be account. However, for the tilde, you can compare any objects. So it will simply give you false because they are of different types. The question was, what if I said the following? Cursor dot item, which is account dot, is equal, and then ID. What's going to happen here? It's important to know. What if I do something like this? It won't compile. Why?
Because cursor.item is equal to item and ID.
Exactly. So now if you call the is equal feature, both must be of the same type. Okay?
So why not use the other one?
Okay, I would say, okay, it's a good question. So this wouldn't even compile because they're of different types. Okay? So I would say usually it might be more convenient for you to use just tilde. Because tilde is actually, save you quite a bit of characters of typing, right? But you got to be careful with the example I just showed it to you, right? Because something compiles, but it may not be exactly what you meant to say. It would be always safe to just say this, like how you did it in Java, I would suggest. But sometimes it might be a little bit more wordy if you say it, right? For example, let's say this. I can tell you practically speaking, right? Why would you use tilde as opposed to is equal? Let's say I got some object O1 dot is equal, and then I got some very incredibly long expression over here. You don't want to put it like that. It'd be much easier if simply say O1 tilde this long expression. It's just easier for you to write, right? Yeah. So you can still feel free to use the tilde. That's absolutely fine. I'm just saying that you have to be careful, okay? Any question about this? Yeah, exactly. So you can see the entry class, you got the is equal feature redefined. So if I say something like this, if let's say I got entry E1, tilde entry E2 over here. If both of them are actually not void, in which case it's going to call that is equal feature that's redefined in the entry class, right? Right. Yeah. Okay. Any questions about this? Okay. Okay? Yes. In this case, I would say, yeah, you can assume that. That's okay. I just want to show you the example, right? You don't really mean to compare account with string. That's my point, right? If it is not, then it's going to call the default is equal. Things wouldn't work, yeah. So I would say whenever you have your own class, you better redefine the is equal feature, like how you did in Java. So for this part, it's no inconsistency, pretty much the same. It's just when you use the tilde, which we don't have the counterpart in Java, you have to be careful. Yes, correct. So the correct way of saying this would be, let me just put it down here, would be say cursor.item.id is equal, right? And then you put ID here. That would be the correct way of saying it. Okay. Okay, good. And I would like to just refer you to some source code. I don't think we should really waste time actually going over the source code. That's pretty much the points I just talked about, just re-emphasizing. I'm going to make this source code available to you. Just go over them. So just reaffirm your understanding for is equal and tilde. Okay, just go over them. Okay, let's not waste time on this. Okay, what I would like to do today, on the way, I'm leading towards writing complete post conditions, especially if the post condition should involve like an array or hash table. I'm going to use array as an example. But before we talk about writing such post conditions, we have to understand exactly how IFO runtime actually caches the values for all expressions. And before we talk about how they do it, we have to know the distinction between reference copy, shallow copy, and deep copy, right? So what I will do is today, at least, I will get through the most technical part about these three kinds of copies, and then maybe in the beginning on Thursday, I will finish the writing complete post condition, and then I'll show you how you can write tests for the contracts, and you'll be completely ready for doing your lab 1. Okay. Okay, so let's just go over from the beginning. It is really something we have to introduce before we talk about the copies. Okay. Okay, let me just start this lecture here. So view, full screen mode. Okay, so it's a new lecture, so I'm going to make it available after class today. Okay, so let's talk about this something called expanded class. You can think of it like compositions in Java. So it's not really like a very odd concept. You do have it in Java. But remember back in 2030, if you want to have compositions, you have to somehow implement that by yourself by ensuring that there's no sharing for the objects, right? So the object structure you're talking about is an integral part of your objects, right? So there's no sharing. However, there is a nice way of doing it in IFO. Okay, let's see how we can do it. Okay, expanded classes. It's quite easy, so I'll just show you by example. Okay, so first of all, before we talk about how you can do it programming-wise, how you can do it from the modeling point of view, it's more like a design. Why would you need a concept like a composition or expanded type? Okay, so sometimes we may want to say objects are the integral parts of certain other objects, so they cannot be shared. For example, so this is actually from your textbook. Okay, so let's say this. Let's read it through. It's informal. Each workstation computer has its own CPU, monitor, and keyboard. So those two workstations will share the same keyboard, right? So they should be the integral part of the workstation. On the other hand, they share the same network, like all the lab computers in Person Lab, right? They share the same network. So now, how do we represent this design over here? So you can see that over here, CPU, monitor, and keyboard, they are more like the integral parts of the workstation. On the other hand, the network that we're talking about here, they can be shared among the workstations. Conceptually, this is how you can write. Okay, so let's just go over this diagram very quickly. You can see over here we got 3 objects of type workstation. Each workstation has an integral part for keyboard. You can see we got 3 different keyboards. Also, we got 3 different CPUs. Also, we got 3 different monitors. On the other hand, for the attributes for the network, they actually just maintain references to the same network objects, right? So you can see over here, we actually got a mix of some attributes are sharing, some other attributes are not sharing. But how can we implement such concept in OOP? Okay, you can figure out how you do it in Java, but this is just modeling. So you do have real life problems like this. But how do we do it in IFO? For example, later on when you do your projects, you may find that some concept might be more naturally implemented using the expanded type, like integral parts. Okay, let's just see how you can do it. Very easy. Basically, you just have to learn just a new keyword. And there are 2 ways for you to program this picture here. There are 2 ways. Okay, very straightforward. First way is, let's say we just define regular reference class. Okay, keyboard, CPU, monitor, and network. At this point, you cannot tell the difference between the classes. They're simply just reference class. However, when we declare the workstation class, here comes the difference. We simply say that the keyboard is expanded, which means the keyboard should appear as an integral part of each workstation. Okay? And similar for CPU and monitor, and for network, just regular semantics. You to maintain a reference to the network. That's one way of writing it. The good thing about this is you only declare expanded when you declare your local variables or attributes. At a class level, you don't have to. Okay, that's option number 1. Option number 2, you can, questions? Yes. Oh no, this is declaring attributes in your class. It's not really about postcondition. Yeah, we're leading towards that eventually. Okay. Okay. So now that's about it. Okay. The second way of writing it would be at a class level, we decide each keyboard, each CPU, and each monitor should be expanded, which means they should never be shared. Okay. So just at a class level. So by the way, you can look up the definition for integer class. Integer class was declared as expanded. Pretty much like how you define primitive types in Java. Let's say primitive int versus expanded integer in IFO. They're pretty much like the same. You only maintain values, not reference to the integer. Okay, we are not programming in C like. Okay, that's expanded class. And then now over here, you can see for the attribute declaration over here, when we say k of type keyboard, we would know it's actually expanded, right? Because at the class level, we say keyboard is expanded. On the other hand, for network, at the class level, it was declared as non-expanded, just reference type. So both ways are completely equivalent. Okay, it's completely up to you which one you prefer. Okay, any question about this before I show you how things would behave if you declare them as expanded? Okay. No, it's not really inheritance over here. It's simply just declaring the attributes to say it should be an integral part of your objects at the runtime. Not really inheritance. Yeah. Yeah.
So, could you quickly go over how you do the same in Java, just to kind of for comparison?
Sure. How about this? Let me prepare some slides, I didn't prepare today to show you Java. How about I do it next time? Okay, I can briefly mention, or at least make a reference. Yeah. The question was, can I show the correspondent thing in Java? I can show you quickly, maybe next time, or maybe early next week. Yes.
So both network and workstation are shared?
Network and workstation. Oh, you can see that over here. Okay, look at this. If you look at the network class over here, it's just regular class. Okay, and then inside the workstation class, we have an attributes n of type network. So that means n is going to maintain a reference to network objects. On the other hand, over here for keyboard, CPU, and monitor, because they were declared as expanded, you wouldn't say you maintain a reference to it. You wouldn't say it. As we'll see some example. You simply say the workstation object contains a keyboard object. And the workstation object contains a CPU object. It does not contain just a reference. Okay? As I actually show you the visualization in the next slide, hopefully that'll be clearer. Yeah. Yeah, keyboard, CPU, monitor, they're not shared. They're expanded. Expanded means no sharing. You just contain, yeah, just no reference. Yeah. Mm-hmm. Okay, why don't we have a look at one example, okay? Very simple example. Hopefully you can demonstrate the behavior. Okay, so now I would like to show you here. First of all, let's look at this class very quickly. So we have an expanded class called B, and we have a feature called change I. It's like a command. And we want to change, so we also attributes I. So we want to change the I value to be some new I value, okay, like a counter, basically. Okay, very easy class, which is expanded, which means whenever you want to run at the runtime, each instance of class B will be contained entirely within other objects. Basically, that's what it means. Okay, but let's see what happened over here. Okay, what I will do is I'll show you the code fragment over here, line by line, and let's discuss it. Okay, over here. Okay, the left-hand side over here is exactly what you just saw. So B and being expanded, right? The same as before. Let's now go through this test feature over here. I also will make the source code available to you. Let's go over that line by line. And I'm also going to visualize what happened at the runtime. So now I want you to look at this. First of all, when we say local EB1, EB2 of type B, okay? If, let's hypothetically, if B was not expanded, let's say B was just a regular class, okay, let's say. If B was not expanded at this point, what would be the value for EB1 and EB2? Void, right? Because we haven't initialized them yet. We have to explicitly create them by using some constructor, like in Java, right? However, now EB1 and EB2, they are expanded, which means they must be contained within some object. So we don't have to initialize this reference. What this would do is something like this, okay? At this point over here, let me just say this is point number 1, okay? It's initial, how about 0? There's a point number 0. It's even before we try to execute any line of the code. At 0 over here, what we have is we simply got 2 objects in the memory automatically allocated and of type B. Okay? And there's no reference over here. You simply say EB1 is simply the name of these objects. And EB2 is simply the name of these objects. And then what about the attributes over here of type integer? And then by default, it's simply going to initialize I to be the default value 0. So these allocations occur automatically even without initializing the objects explicitly by yourself. Okay, that's one thing that's different. Okay, so there's no void concept in the expanded types. Okay, that's point number 0. Okay, so that's why when you look at the first assertion over here, you can see that over here, our result is assigned to. I'll talk more about how you can write test cases on Thursday. Just give you some quick overview, because I suppose you also studied through the tutorial videos, which show you how you can write test cases. Okay, over here, we simply say EB1, EB1.I, and EB2.I. You can see they're both 0, right, in this case. So this should be true. Okay, so this should be simply true. True at this point. You can see the main thing to notice is the yellow highlight over there, there's no object creations beforehand. As soon as you declare the variables to be expanded type, you will initialize for you automatically. That's for expanded type. Okay, so now let's see the next one. The next one to look at is over here. Result is assigned to EB1 is equal to EB2. Okay? Okay, well, if you look at the visualization over here, what it will do over here, if B were not expanded, what would this do? EB1 equals EB2. You will compare the references, right? But now, since they are expanded, the meaning is a little bit different. I will have a summary slide for you after this. But for expanded type, if you put a single equal in between them, that means either will compare their contents recursively for you. Okay? So now in this case, simple case, they will simply compare each attribute, in this case I, which is 0 and 0. So that'll give you true. So you can imagine a very straightforward exam question. I'll give you 2 questions there. Question number 1, I will keep B to be expanded. Question number 2, I get rid of expanded. And the answer might be slightly different, right? Why don't you try? Okay, and convince yourself. Yes? Oh, you mean E1 and E2, EB1, EB2 are different types? No, it wouldn't even compile. Because when you compare using equality, single equality there, it's pretty much like a is equal. So if both sides are not of the same type, you cannot compare, right? Yes, question, yeah.
If EB1 and EB2 are not expanded and you use EB1 equals EB2, that would mean they're both void?
Yes, correct. If they're both void, that will also give you true. However, if you try to create EB1 and EB2 beforehand, they'll be false, right? Because they are different objects, different addresses, right?
So if I don't expand the class
Mhm.
and I compare these two,
Mhm.
should be true also?
Okay, good question. Okay, yeah. Okay.
It's all going to be void, right?
Okay, how about this? Yes, correct. Let me make it very precise for you, otherwise you will get confused. Let's say we have class B, okay, and everything else the same as before. And then we have our test over here. And then we have, let's say, local EB1, EB2 of type B, right? B is not expanded. Okay, and then do. Let's first of all, let's do a comparison right away. EB1 equals EB2. What would that be? Should be true, right? Because we're just comparing references of the two objects without initializing them first, in which case both of them will be void. Give me one moment. Yeah. In that case, it will just be true. Yeah, let me finish this part and then we'll take a question. Okay, let's say after this line over here, let's say the following. We say creates EB1 dot make. Let's say make some initial value, for example, just 1. Okay, just 1. And then we say creates EB2 dot make. And then we say 2. Oh, sorry, I want to make just the same value, also 1. Okay, so now if we do same comparison over here, if we say EB1 equals EB2, false, right? Because in this case, it's a reference semantics, which means they're going to be of different objects, different addresses. So that should be false. Okay? Just don't get confused. We're just adding one new type of objects. So expanded type versus reference type. Okay? Yes. Sure. It will call whatever the default create it is in the string type. So the question was, what if, let's make the B still expanded, let's make the one more attributes. For example, we can say S of type string. In this case, as I said before, at point number 0, it should really initialize the objects automatically by the runtime. So what would be the value for this? You know what? It's a good question. I think in this case, you can see string is a reference type, right? Yeah. And if string is a reference type, it will simply give the default value to the string. Yeah? No, default value for string will be void. That's what you would do.
Wait, but if this is supposed to be like safe and supposed to follow void safety rules and whatnot, that won't work, will it?
No, void safe. Okay, it's a good question. Okay, let me finish the drawing first and then I'll mention that. There's no conflict over here. Okay, over here you have string S and then, I shouldn't say null, right? Void. Okay, I want you to also get used to it, otherwise you wouldn't know what the compiler is trying to say to you. Okay, so that would be just basically what the runtime would do is simply give you the default values for every attribute. If the attribute is simply reference type, just give it void. If there's like an integer, give it 0. If there's a Boolean, give it false, right? And now, does this violate the void safety principle, which we haven't talked about yet, but it's a very quick preview. In this case, as long as you haven't used eb1.s yet, okay? Which means, for example, you can see so far we haven't really used eb1.s, right? However, after this point, if you try to say eb1.s dot append, for example, and some string value over here. In this case, the compiler should complain, right? Because S may not have been initialized yet.
But void safety doesn't necessarily mean you have to initialize everything to some.
Basically, void safety means as long as you have one single usage of your attributes of reference type, it might be void. When you use it, then it's going to complain. But in this case, we haven't used S yet. How about this? Let me save this example here. When I talk about void safety, we can talk about it again. Okay, yeah. But don't lose the point. Basically, for expanded type, somehow the runtime will just initialize everything for you. Okay? Okay, let's go on to go through the rest. Yes?
So if S in EV1 and S in EV2
Mhm.
references to different values,
Mm.
and you try to use the equality operator on them, would it return false or?
So the question was, what if, let's say, what if the, let me just erase this for now. What if I put, let's say, Jim over here, so not void, and over here I put Alan. In this case, EB1 equals EB2, right? Basically, what you will do is as follows. For expanded type, it will simply compare the values 0 and 0. They are simply equal. On the other hand, if it's a reference type, what you will do is you will call the isEqual feature for that particular class, in this case, string class. So in this case, Jim and Alan are considered as different contents. So it's not the same. On the other hand, if I put something over here, let's say Jim and Jim, it will be considered as the same because the isEqual feature in the string class tells you they should be the same. Yeah, okay, it's a very brief answer to your question. Okay, let's go on, okay? So now let me just, of course, when you see the video, you can see how I drew the complicated picture. But let me, for us to go on for the rest of the code, let me just erase this part over here, okay? Just this part. So we can see exactly how things should go for the rest. Okay, let's now go to the next line. Okay, we just did this line over here. It should be true. And then what about this one here? EB2.change I, 15. Okay, in this case, well, apparently you can see that we're only modifying this to be 15, which has nothing to do with the copy of 0 over here, right? So that is why when you see over here, we try to reassign EB1.I is equal to 0. That should be true. EB2.I should be 15. That's also true. So overall, it will be true. And let's now do the following to say here. Result is assigned to EB1 not equal to EB2. It should be true, right? Because in this case, it's assigning, right? Yeah, that's it. Yeah. So you can see that basically, I'm just showing you some simple example to show you. We're just talking about different expanded objects. In this case, because their contents are different, so they are not considered as equal, right?
Professor, in an old block, we never actually needed to like create an object. So is it like static classes in Java where you don't create an object but you still?
You know what? It's not really like a static class because in this case, you do have some states for your objects. So not exactly the same. Yeah. Mm-hmm. Yeah. Questions? Yeah. Line 12 over there, it will return true. Yes, correct.
I'll change the other 0.
Mm-hmm.
So
Oh, yeah.
I make it, let's say I make
Yeah,
it 15.
absolutely. Okay, let me just go over that. Very, very good question. Let's continue with the code. Let's say after this, we can say EB1 dot change I. Let me use a different color so it's easier for you to see. That's just an extension. When you see the source code, you can also feel free to modify that. So I can say EB1 dot change I. And then to be 15. Okay, that's what you're suggesting. And then let's do exactly the same assertion as here. Let's say result is assigned to EB1 is not equal to EB2. Okay, because I already changed this to be 15 as well. So they are now considered as equal. So when you say they are not equal, that should be false. Right? Good question.
But they don't compare the reference.
They just compare contents, yes.
Okay.
Yeah. Mm-hmm.
Why did they compare the references over there when you
Oh,
made it?
okay. The reason that you compare the references over here was because this was only hypothetical to say B is not expanded, in which case just go back to the reference semantics, right? Okay, so the conclusion is you have to see whether the class you're talking about is expanded or not expanded. So we've got two kinds of types, okay? When you talk about expanded, it's pretty much like a no sharing. When you talk about reference type, it's just like how we have understood about reference types so far. Okay, let's see what else. Okay. Okay, that's about this example here. Okay, you can just go through them. So that's exactly what we have just went through. Okay, so now what you should really bear in mind is in IFO there are two kinds of types, either reference type or expanded types. In Java, we used to say either primitive or reference. In IFO, it's reference or expanded. Okay. Okay, so every entity must be either reference type or expanded type. Let's just summarize how things will work. Okay, so first of all, for reference type, like what we learned before. So whenever you talk about variable of reference type, it only stores the address, right? It does not store the entire objects. And when you say x is assigned to y, you're copying the address that is stored in y into x, right? That's how we got aliasing. Okay. By the way, are you guys comfortable with the word aliasing? Really? Aliasing, no? Okay. How about this? I promise that I'll bring you some interesting. To be honest to me, how many of you are not really comfortable with the idea of aliasing?
I've only heard it in like video games.
It's different. Well, okay. How about this? I would briefly describe what aliasing is. Maybe you know about the concept without knowing it's called aliasing, right? Yeah. Could be possible, right? How about I look at that? That's really gonna be very important for the rest of the discussion. It's worth just confirming. Okay, something like this. Can we assume that we have a point class? Okay, point class with x and y. If I say something like this, okay, it doesn't matter if I use Java or IFO. Okay, it's just easier to write for this aliasing example. Let's say point P1 is assigned to new point 3 and 4. Point P2 is assigned to P1. Okay, let's say print line P1.x followed by a comma plus P1.y. Mm-hmm. Oh yeah, of course. That's exactly what I said in the first class, right? So, well, of course, if you don't like my handwriting, you can definitely copy the notes, right, by yourself. But if you're okay, then yeah, everything's recorded, everything. Yeah. Well, if you don't like my voice, you can mute it out, right, on the YouTube. That's also fine. I don't mind. Okay, good. Now let's say the following. If I say P2 dot move up by 2 units, which means the y units must be incremented by 2, right? Okay, and then I do exactly the same print line. P1.x, P1.x, followed by comma plus P1.y. Okay, let me just remind you for this example here, you can see that over here the context object is P1. When I do the changes over here, the context object is P2. Okay? Okay, now can you tell me what should be the output from here? 3, 4. Okay, that should be very easy. Now, question is, the next line, I try to move up P2 by 2 units. Have a question before you say the answer. Yes. Well, this example is about aliasing, right? Yeah. So of course, why would I talk about something nothing to do with aliasing, right? Okay, what should be the output over here? 3, 6, right? Okay, 3, 6. Okay. 3, 6. Okay, let me just briefly say what aliasing is. Okay, so at this point, so for this line over here, we got P1 pointing to an object over here of type point, and we got x and y, 3 and 4. And now here comes the critical thing. Whenever you say P2 is assigned to P1, that means copy whatever address that is stored in P1 into P2. That means P2 is now pointing to the same objects as P1. Aliasing simply means an object has 2 different names, has more than 1 name. That's what aliasing means. In real life, if a person has more than 1 name, you can say they got different aliases, right? That's what it means. Okay, and now, so that's why when over there you say P2 that move up by 2 units, but it's as if you put P1 that move up, the same effect. That's why when you say P1.x in the last line, it would be 3, 6. Are you guys comfortable with this? That's aliasing. Okay, good. So I don't need to repeat. Okay. Yeah, okay, yeah. So in general, let me just say that one more, and then we are done with this. Yeah, you can have aliasing for any object. So let's say in general, if you have an object in the memory. Okay, guys. Okay, in general, if you have an object in the memory, you can have as many names as you like to the same objects. And the idea is, if you try to change the object by using one of the names, it doesn't matter which one you use. As long as you use one of them, the effects of changes to the objects is going to be visible to all the other names. Okay, that's aliasing. Okay, yes, question.
If we then update P1
Mm-hmm.
with P2 point.
Good question. Let me do a little bit continuation from this since we have gone this far. What about, let's go a little bit further. So now let's say P1 dot move left by 3 units. Okay, afterwards I would say print line P2 dot x P2 dot x plus P2 dot y. Okay, what would this be? 0.6, right? 0.6. Because over here, again, you can see, let me just show you again. Over here, in this line here, when you say P2 that move up, P2 is pointing to this object over here, move up by 2 units, that will change that to 6. When we talk about this line over here, sorry, not this line. When we talk about this line over here, we're using P1, and P1 is pointing to just the same objects, and move left by 3, so that'll change that to 0. Okay, that's aliasing. Okay, we do the aliasing somehow for copy. That's why you got to understand. And because of aliasing, we realize sometimes when you write a contracts, you don't just want to do reference copy. Sometimes not even shallow copy. You might want to go for deep copy, right? So that's something we'll get into. Okay. Okay, very good. So everybody's hopefully on the same page, and we go on. Not here. Okay, that's about, okay, for expanded types over here, so usually when you say an object of expanded type, you don't talk about reference, just talk about the objects, okay, the contents. And then over here, when you say X is assigned to Y, this one is interesting. You don't copy the address anymore. You copy the entire objects to that object. Just make a attribute to attribute copy, basically. Okay, that's the meaning. And then, finally, when you see X is equals Y, that simply just compare the contents. Pretty much like when you do tilde. Okay, just compare the contents. Okay, one more concluding problem for expanded types, and then we're going to talk about copies of objects. Okay, so now the problem is every published book has an author. Every author may publish more than 1 book. So now, can you think about, okay, I would say in this case, either use a reference type or expanded type for the author is completely up to you. It's more like a judgment call. You just have to somehow justify to see which one is more appropriate for your application. But now, can you just imagine for a moment, if I say I have a book object over there, if the attribute author happens to be reference type versus it is actually expanded type, how would the runtime look differently? That's a question. Questions? Or you just want to answer? Hmm?
There's an answer to your question.
Okay, go ahead. Yes.
So if you had a book that pointed to the name of the author, and one of the books, by some magic, the author changed.
Mm-hmm.
Therefore, the author is going to change also for every other book type that has that same
Yeah,
author.
you're talking about aliasing, basically. You're saying that for all the books that the same author wrote, so they will point to the same author objects.
Right.
And now if I modify that particular author object there, every book that is being published by the author can actually see that change,
So
right?
would it be safer to have an expanded type? Because if in the case the author changes, you won't have...
That's one argument, but I would say being expanded type can also be useful sometimes because you do want to maintain different copies of the author's information. maybe, I'm not sure why, but sometimes you may want to maintain different copies. Yeah.
But at the same time, will make it very redundant if you have to change the same.
But yeah, but what I would say is sometimes for your application, redundancy might be required. You just want to keep separate copies of your information sometimes. Yeah, you'll be safer, yes. Okay, let me just show you the diagram very quickly. So basically for this problem here, there's no standard solution. I'm just trying to say you should know the difference, okay? If it's a reference type, you can see every book by the same author refers to the same object as I said before. If now I change the information for this particular author, then it will change for every book, right? That's an efficiency, I agree. On the other hand, in this case, if we say the author is of expanded type, in that case, every book has a separate copy of the author, right? Okay, I would say how you do it is completely up to what your application requires. Okay, any question about the difference between the diagrams over here?
Sorry, can you just repeat what you said about the first part, the reference type?
Yeah, so for the, yeah, sure. So the left diagram over there we know that the author attribute over here, let me just use cursor here. The author attributes of reference type, which means they point to the same author objects. So they are shared, that's aliasing. On the other hand, on the right-hand side over here, the author attributes expanded type, which means even though the same book, even though the books are written by the same author, but just different records, which means if I change the author record for this particular book, it's not going to modify the author record for the other one, right? They're separate copies. Questions? Yeah, questions? Yeah, that's fine.
So if you define a class as being expanded,
Mm-hmm.
all of the operators and methods that, not methods,
Feature, yeah.
all the features, all the operators that go with it stop you from being able to define it, like have another reference to that same object, right?
Not really. I would say, you know what? I think try to overthinking. So basically, for expanded type or reference type, the way you call the features or methods are just the same. You got a context object over there. It's only the matter of if the object itself is expanded or reference.
No, what I'm saying is if you define something as expanded,
Mm-hmm.
there's absolutely no way, Jose, that you'd be able to refer to that same object
You can
with another name.
Yeah, correct. That's correct. Very good. Yes. Okay. Oh, let me show you one thing. Okay, that's a good question. So can we just look at very quickly this picture over here? Okay, I'll demonstrate to you. It's a good question. So let me just emphasize what we just said, and then we are done with expanded, and then we go to copying objects. Okay, are we okay with this diagram here? Okay, I'm going to illustrate something to you. Let's say, how about this for now? Let's say this is book 1, B1, and this is book 2, B2. Okay, B1 and B2. Okay, let's try the following. So we got B1. B1 is pointing to some book objects, and the author is like this. And B2 is pointing to another book object over here, and like that. Okay? So now, for the moment, can we just assume it's different books and different authors? So now, can I say this is the author for B1, and this is the author for B2, for now. So now, no sharing, because if you attempt to do the following, B1 dot author is assigned to B2 dot author. That's what you will usually do if they're reference types to do sharing, right? If you do that, what's going to happen? No, not void. Remember what we said before, when they're expanded type, when you do assignments, what do? Do they copy reference or they copy contents? Contents, right? So what this will do in the diagram, I should do the following. Yup. Exactly. So that's going to be green instead. However, this green and this green, they're separate greens, if that makes sense, right? They're not shared. Okay? Chris? I'm saying, yep, expanded, the concept there is not unique. It's pretty much like a composition. You just got to do maintain the composition yourself. Composition, yeah.
Like that's an actual thing in Java, composition.
Right, it's like a concept. That's the term we use in 2030, called composition.
Oh, is it?
Yeah. Questions?
So say you have an expanded class,
Mm-hmm.
but you want to copy it by reference. Is there a way
No, actually, if you got expanded type, you cannot copy by reference.
to
You must copy, yeah. Otherwise, you would have used reference type in the first place. Guys, please, right? I would say, yeah. I would say at the top level, if you declare one class to be expanded, that means when you talk about objects of that type, when you say assignment, that definitely copy the contents. You're forced into that, right? Okay? Yes.
So this will copy the author from B2 into B1.
Exactly, just copy, yeah, but they're separate copies.
So what if that B2 author, let's say it was an expanded class as well?
Mm-hmm.
Well, I mean, it is an expanded
Yeah.
class, but let's say it had one more attribute, like birth date of the author,
Mm-hmm.
and now you did that. Now you did B1.author, assigning
You're saying the author object also has a field called birthday, okay? Okay, the question was like this. Conceptually, okay, can we just do this? Okay, let me undo this back to here. Okay, over here. Okay, it used to be orange over here. Okay, let's make it a little bit more complicated. Let's say part of the author is it has maybe an object of type, let's say birthday. Okay, birthday. And then similarly, it also has a birthday object over here. Okay, now, if I say B1.author is assigned to B2.author, how is it going to do it? Okay, that's what your question is, right? So now I have a question for you. Do you want birthday itself to be expanded or referenced? Okay, how about we try both cases? By the way, for expanded class, the attributes in the expanded class may either be referenced or expanded. Okay, there's no conflict over here. Okay, let's do two cases, okay? Two cases. Case number one. Let me just say there's a BD, okay, just for birthday attributes. And then this one also is called BD, right? If BD is expanded type, you know what? Let me just be consistent with the color over here. Okay, expanded types is easier to understand. In this case, just copy recursively, right? What it will do is, it will simply do the following. Let me just redraw the diagram. After that, you should get B1 is referring to some book over here, and B2 is also referring to some book over here, right? And then we got over here author and also author, okay? After which we should also refer to some birthday and also refer to some birthday, right? So now the question is, if birthday class is actually expanded, that means we'll copy all the contents. There's no sharing of the objects. So that means B2, which doesn't change, used to be green, we simply copy recursively to be there. Just copy, okay? On the other hand, if the birthday attribute over there is reference type, it'll be slightly different. That means we have some sharing over there. A little bit sharing, we do. Let me just draw it quickly. Okay, case number two. Let's say BD is reference type, in which case it's easy to draw over here. So that means we're going to basically, okay, let me just draw this. First of all, we're going to basically, it becomes green over here. However, the birthday attribute field is going to be sharing with this birthday. Okay? That's why it's going to happen. Okay? Basically, we copy the object for expanded, but since, and then we copy attribute by attributes. If the attribute is expanded type, copy the contents recursively. If the attribute is reference type, just copy its reference. Okay? Okay?
What if the author is reference, but the birthday is expanded?
Well, the same. Wow. You guys are trying to throw me different cases, right? Okay. How about this? You should really, let's do one more, okay? Well, I'm glad you got so many curiosity. That's good. We can try one more, and then we should really move on, okay? Otherwise, we'll never finish the topic, okay? Let's try this. Basically, you're trying to say Can you say that again?
Author is reference.
Okay, sure. Okay, so now B1 is pointing to some book, and B2 is pointing to some book. You're saying the author is reference, right? The author is pointing to some author objects over here, and the BD is expanded, right? Good. It's actually simpler than you might think. BD is over here, is pointing to some birthday objects. Okay, and B2, let's say over here, author is pointing to some author objects and which has a BD, okay, which is expanded. Okay, so now when I say B1 the author is assigned to B2 the author. Okay, so now it's easy because remember we said for assignments if both sides are reference type, what will we do? Just copy the reference, right? So in that case, it's simply like this. So B1, the author, rather than pointing to here, is going to point to here, just like that. It's a good question. Okay, any more questions? Since we discussed this much, then I can take more if you like. Yes.
It has to be with to be shared.
Yeah, to be shared. Because basically, we just analyzed the assignments over there, right? Because the assignments over there, colon equal, has reference type. Yeah, that's why. Okay, good. Now, let's now move on. Okay, but if you have more questions, feel free to ask, maybe in the lab or in the office hour. Okay, now we talk about copying objects. Okay, what I would do is I'll give you some general principle about copying objects. And now, when we talk about copying objects, the objects might be reference type or it might be expanded type. So it depends. I'll show you the different situation over here, and then I'll give you one example about array. Okay, let's just go over the principle very quickly. Okay, so copying objects. Generally speaking, so let's say we got two variables, C1 and C2. Okay, and they're of type the class C. Okay. Type C. And let's say we got an attributes A in C1 and let's say in this class C we got an attribute called A. Okay? And then the attribute can be either expanded type or reference type. Right? So far so good? Just in general. Of course, in general, specifically you may have more than one attribute in your class, but let's just make it simple. Okay? So now let's just say this diagram here. Let me just go over that quickly with you, and then I will demonstrate to you how the different cases will work. Let's say C1 over here is pointing to a C objects, and A, which is attributes, is pointing to some structure. Okay, I'll just put a cloud. It can be as complicated as you might like. And then C2 over here is pointing to just another C objects, and then C2.A is just pointing to another cloud, just another structure. Okay, that's the setup. Okay, are we okay with this? Okay, C1.A can be as simple as a single integer, or can be as complicated as some objects with very complicated structure. Okay, like that. Okay, so what I will do is I will show you the three different cases how you can consider the copy. And the slides got some wordings over there you can read over. So I'll just illustrate to you right away. Okay, reference copy. Okay, so when I simply do something like this, when I simply do C1 is assigned to C2. Oh, for the moment, let's assume C1 and C2 are simply reference type for the moment. Okay. So now this one should be rather easy, right? If I do C1 is assigned to C2, that means I'll simply say C1 rather than pointing to here, just point to there. Okay, so we do have aliasing. For example, if you say C1 equals C2, should be true. Similarly, if I say C1.A equals C2.A, you will also be true. Agree? They point to the same objects. Okay? There is a reason why we have to understand each scenario carefully. That will affect the way you write contracts. Okay? So we will see. Okay, reference copy is easy. Okay, shallow copy in iPhone is using a feature called .twin. Okay, twin. That's for shallow copy. Let's see how we can understand this. Okay. The shallow copy principle is easy. You create the same objects of the same type, and you only do a first level copy. First level. What do I mean by first level? Let's illustrate that right away. So first of all, we're going to create just another object of type C, just over here. Okay. Oh, questions? Oh no. Okay. We just no copy just yet. Okay. Copy is happening. Okay. So yeah, bear with me. So basically, we just create an object of type C with attribute A, right? Okay. So now, what should be the value for attribute A? Okay. Basically, we're going to make a copy, and the way we make a copy is to say something like this. Can we just temporarily say this is a C3? Temporarily. Okay. So C3.A is simply assigned to C2.A. That's how we make the copy, which means we do have a new object at this level here, but starting from the second level, we do have some sharing over here. Are you okay so far? So we'll only do a first level copying, only the first level. There's no recursive copying, just the first level. And then after this, you can think about C3 is just behind the scene. You don't really see that, okay? And after this, what we will do is C1, rather than pointing to here, is going to point to over here. Okay, let's compare. After this, if I say C1 equals C2, true or false? False. Well, okay, false, right? Because you talk about different objects over here, right? On the other hand, if you say C1.A equals C2.A, you're not guessing, right? Well, you want to see the diagram, right? Okay, let me make a diagram more vivid to you. Okay, when I say C1.A is pointing to this object over here, right? And when I say C2.A is also pointing to this object here, pointing to the same object, right? So that should be true. Okay, that's a shallow copy. Okay. Okay, questions? The false. Oh, okay. C1 and C2, no problem. When you look at that, okay, that's a very good question. How about this? Let me just make when you talk about C1 and C2, okay, C1 and C2 over here, you're just talking about the address for this objects versus the address for this objects. They're different objects, right? As you can, they have different boxes. So that's why they are different. On the other hand, C1.A is referring to this structure over here, and C2.A is also referring to this structure. That's why they are the same. Questions?
Does IPL automatically garbage collect and kill the old value of?
Oh yeah, you don't have to worry about garbage collection. It does handle that, like how you do in any other OOP. Yeah, good question. Okay, okay, that's about shallow copy. Okay, deep copy. Deep copy goes to very extreme. You do first level, second level, third level, as much further as that's necessary. Okay, conceptually, this is how you think of it. Okay, we'll see. So now again, the very first step is similar to the shallow copy. First of all, you have to, let's say temporarily, let me use the same color here. You have C3, just temporary variable. C3 is pointing to the newly created object of type C, with attribute A, right? Up to now, it's the same as shallow copy. However, over here, when we do, how do we assign C3.A? It's assigned to what? We used to say C3.A is simply assigned to C2.A. That's what we used to say. But now over here, we have to do this recursively. So what we do is we're going to say C2.A dot deep twin. You can think of this is more like making a recursive call to the deep twin. So that means you will go as deep as necessary, depending on how complicated C2.A is. You just do the deep twin. Okay? So what you will do is something like this. Okay? So after this, what we will get is something like this. So it's going to point to a separate cloud over here is simply C2.A dot deep twin. Like that. And then afterwards, you would say C1, rather than pointing to here, is pointing to over here. Okay, let's do the same assertion checks. Okay? If you say C1 equals C2, False, right? Because you're talking about different objects over here. Okay, should be false. And let's do another one. C1.A equals C2.A. False, which is different from what we said before, which was true, right, for shallow copy. So this will also be false. Okay, guys, it's only a concept. I'll give you a concrete example in the next slide. But before I go on there, any questions about this? Yes?
What do you mean by first level? Is it just like the first attribute?
Yeah, basically all the attributes for, when I say first level, thinking this way, over here, this is the object that we just created. All the attributes it contains is its first level. All the attributes of its attributes is second level. Okay? Yeah. Mm-hmm. If you think about in 2011, this is more like a graph, right? It's like the first time you do the breadth first search, right? If you're on the second level, just go further within the edge. Yes.
Why are you changing the reference from the C1? You're changing the reference.
Oh, because remember what we wanted to do originally was this. We wanted to do to say C1 is assigned to C2 the deep twin. But to really calculate C2 the deep twin, we just temporarily use C3. But that's only behind the scene. Once we completed the deep twin, we can say C1 is reassigned to this particular C2 the deep twin. That's why. Okay? Yeah. Any question? Yes.
For both shallow copy and deep copy, did
Yeah.
it always create a new object C3?
Correct. Correct. For a shallow copy and deep copy, the first step is the same. But for shallow copy, you stop at the second step by making just a reference copy. For the deep copy, you go on as further as you need, depending on how complicated C2.A is. Okay? Why don't we do some example? Okay, concrete one. And there are different versions for this particular example, so let's just see how many we can go through. Okay, we do have some time, about 10 or 15 minutes. We'll see. Okay, so now, okay, so these are basically diagrams that go through. You can go through the wording, basically exactly what I said, so you can just go through them. So what I would like to do, I will leave this as an exercise for you. This is actually from your textbook for OOSC2. Okay, this one is rather easy to understand. I would like you to convince yourself this is really the case for twin and deep twin, a reference copy. Right? Let's do something different from your textbook, freshly made. Okay, so let's. This will be directly relevant to writing post conditions for collections, especially array or linked list or hash table. For any programming language, object-oriented programming language, whenever you have, this is simple. Whenever you declare a variable of certain class type, that means store addresses, right? That's something you know already. Okay, just address. Let's assume the following declarations. Let's say we have imp and we have old imp. So these two variables are local variables. They could be attributes, but I should make them local variables. So these two local variables are of the same type. Okay? I just say imp and oimp for a particular reason. As we start our lecture on Thursday, we're going to see how these kind of a copy can be maintained by the runtime system automatically. Okay? But today we'll just do it manually. Okay? So we got imp and oimp, just array of string. And then this, so initially just make the, okay, we just change the imp array over here, make it empty initially, and then we just force 3 string values to it, Alan, Mark, and Tom, okay, to indices 1, 2, and 3. Okay? Are you convinced that after this manipulation over here, the array looks like this? Right? So that means imp over here is basically an array. Okay, an array which has indices 1, 2, and 3, because we forced it into 1, 2, and 3. And then we got a 3 string objects over here. Okay, so far so good? Okay, good. If you're convinced with that, so we're going to see different manipulations. Okay? Yeah. In this case, because remember over there, we simply say force, and then 1, 2, and 3, there's no 0. By default, the array starts with 0. By default, the array indices. Yeah. Of course, you can rebase it if you like to 0. It's up to you. Okay, let's do the first example here. Oh, actually, before that, okay. Okay, so now we're going to see how old imp can be created. So we're going to see different examples, especially once we do either reference copy, shallow copy, or deep copy. We want to see for how can we inquire about the structure after doing the copy. Okay, we'll see. Okay, let's see the first fragment of code. Let's say we simply do a reference copy. We say old imp is assigned to imp. Okay, let's change to iPad right away. Let me see if I can just close this very quickly. It's a little bit getting to the way. Okay, we'll see the reference copy. Just bear with me with 10 seconds. I shouldn't have done that. Okay. Okay, so now what's going to happen if we say old imp is assigned to imp? So what's going to happen here? Well, apparently, do we have to make any copy at the first level? Do we have to create any new array objects? Nope. So old imp basically is alias, just pointing to here, right? Reference copy. Okay, that's good. So far, so good. Okay, let's go further with the example over here. Okay, let me be careful. I don't want to close the wrong thing. Okay, so now let's see the original slides over here. View, and then full screen mode. Okay, next one. Next slide. So let's say when we say old imp is equals imp, should that be true or false? True. Very good. Okay, let's say the following. I say imp at position 2 is assigned to Jim. Imp at position 2 is assigned to Jim. Imp at position 2, which is over here, is assigned to Jim, which means rather than pointing to here, it is going to point to a new string object over here, and where the value is Jim. Okay, you can see so far there's no duplication of the array, just the string objects as we need it. Okay, so now, can you tell me what's going to be the result after this cross loop, 5, 6, and 7? What we're doing over here is simply to say the old imp and the imp, they contain exactly the same string values. Yes, true? Well, should be trivially true, right? Because they point to the same array. Of course, they contain the same. Now, imagine this. If somehow your post condition, well, that's something I will try to illustrate to you on Thursday. Whenever you're trying to do, you want to make sure the way IFO caches the value for your implementation is not by doing a reference copy. Because if IFO simply caches your value of the array using reference copy, then whatever changes you make, you're making to the same array. So that means when you compare the pre and post states, they are the same, no matter what. Okay, that's one thing to note. Okay, but that's something I'll make another example to show you. Okay, let's go on. So this one's easy, just true. Okay, exactly the same diagram as I drew. The second one is interesting. Okay, so let's do a shallow copy. Okay, so now how would we draw the shallow copy over here? So let's say over here, let me put it here. Imp, old imp is assigned to imp dot twin. Okay, let me put old. What should we do? Should we create a new array? Yes, thank you. So let's create a new array. Okay, array of string, and then of the same size. Do we have to create any string objects? No, we only make references to them. First of all, we should really say old imp should really be pointing to this array over here, and then each one of them is pointing to the same objects over here. Okay? Which means, for example, imp at position 1 equals old imp at position 1 is the same. Right? It's true. On the other hand, when you say imp is equals old imp, that should be false. Okay? Now here comes the interesting thing. Okay? Let's try the following, the next line. Okay, so far so good. Let's say we change the imp at position 2 to be Jim, like what we did before. Let's do that first. So imp at position 2 is this slot over here. We want to change that to be a new string. I'll just put it here. It's a new string object over here of type of content Jim. Okay. So now, question for you. Okay. Are you okay with the diagram so far? Okay, good. Now, let's do the same check. The same. I want to compare the two arrays one by one. Are they the same? Are you sure? I can go back, yes. No. Look at the diagram. Okay, how about we'll do it. No. Let's do it. Let's do it in slow motion. How about this? Imp at position 1, tell the old imp at position 1. Would that be true or false? True, right? Imp at position 2, tell the old imp at position 2. False, because one is pointing to Jim, which we got reassigned, and the other one is pointing to Mark. So that means this kind of shallow copy here can catch some change on the original implementation. However, it does have its limitation. Can you see what the limitation is? What's the special feature about shallow copy? It only does a copy at the first level, right? It does stop.
So, okay, I thought that it actually did, imp at array number 2 actually changes to Jim. I thought it was the other way around, because if you do that, then the old imp 2 is going to see the exact same change, and that's going to change to Jim as well, right?
No, it wouldn't, because you can see imp at position 2 is assigned to Jim. That means imp at position 2 is pointing to Jim. But we didn't change O imp.
Wait a second. Oh, wait, strings are immutable. That's not.
No, nothing to do with immutable. Nothing to do with that.
But like,
Okay, how about this? Save that one. Okay, let's see at the next one. Okay, so far so good. Okay, so what's the limitation for shallow copy? If your change is only limited to the first level, shallow copy can catch that. If your change is beyond the first level, it cannot catch that. Let's see one example. What can be a change on the second level? Let's say we don't do any reassignments of the array position 1. Let's say it still point to the same mark string objects. What about we just change the contents of the string objects? Why don't we have a look? Okay, so now let's see over here. Let's see okay, this one we know that should be false, right? Okay, let's go over this one and then we're done. Okay, so now let's say we still do the shallow copy over here. Okay, so now I would like you to look at the code over here, specifically line number 3, while I'm trying to draw the shallow copy, and then we look at that together. Okay. Okay, so specifically, could you please pay attention to line number 3? So we are not really trying to reassign position 2 to be something else. We are changing the object specifically. We're trying to append. So string in IFO is not immutable. It is mutable. Okay, so over here, what do we do? Okay, so now let's go to the diagram over here. So now over here, when we say imp at position 2 dot append, with 3 star over here. So what do we do? Well, basically, we are saying that rather than mark, append, star, star, star. Okay, so now let's go, okay, keep this diagram in mind. So there's no new string object created. We're making a second level change beyond the first level already. Now, oh, sorry, I shouldn't show you. You didn't see that, did you? Okay, you did see it. Okay, pretend you didn't see it. Should that be true or false? Why? Why should that be true?
wait, let me do this time. I have to redeem myself.
Good.
So, okay, essentially, because both, this is a shallow copy and it doesn't extend beyond the first level.
Yeah.
Because strings are reference objects, both the second index
Mhm.
old and the new object point
Yeah.
to the exact same
String objects.
continuous.
Yeah.
And so if one of them you change it,
Mhm.
the other one will be that exact same.
Yeah, exactly. Yeah. Okay, so guys, let me make a conclusion and then we are done. Okay. So basically over here, it would be true. Okay, guys, can you just give me 2 minutes? Okay. Yeah. Let me make a mini conclusion here. So you can see that for the first example for the shallow copy, you cannot tell the it could tell the difference, but in this case, it cannot tell. Okay, study these two examples carefully. We'll get to the decopy in the beginning on Thursday, and then I'll show you how this can be applied in post-condition writing. Okay, see you then.